Hi everyone and welcome back to DevPortal, your go-to channel for mastering database concept. In today's tutorial, we are diving into one of the most confusing behavior that developer notice while working in a PostgreSDB is that when does Postgres choose a sequential scan even when an index exists for that table. This is very critical aspect when anyone is working on the performance tuning. So first, let's discuss what we are going to cover today under this tutorial. We will start our discussion with the question what is a sequential scan, and then we will discuss that when Postgres will choose sequential scan and when it will do index scanning. Along with this, we will see some of the reasons that why Postgres will ignore the indexes, and along with this we will see a real world example as well for your sequential scanning and index scanning, and we will discuss that how we can force Postgres to do index scanning on the table. All these things we are going to cover today under this tutorial. So let's start our today's video. So what is a sequential scan? A sequential scan means when Postgres read the entire table row by row, even if we have a filter in the query. It usually happens when there is no suitable index exists in the table, or when Postgres estimate that reading all the rows is cheaper compared to the reading the data using the index. In that case, it will do the sequential scanning. Now the question arises that when does Postgres use an index scan? Suppose when we have a where clause in our query, in that case the clause which we have mentioned that is properly indexed. In that case, Postgres will do the index scanning on that table. And second is that when Postgres will identify using the query planner is that the index scanning is cheaper compared to the sequential scanning. In that case, Postgres will do the index scanning. Let me show you with the help of an example. One table already I have created with 50 million records. Let me show you first. So I will write select, and let me first show you the count. So I will write select count from schema, that is tutorial dot employees. So this is the table which I have created under this schema tutorial, and I have inserted 50 million records. Let me show you. So it will take some time, so let's wait to complete the query first, and then we will find that it contains the 50 million records. As you can see, it is taking a lot of time to fetch the aggregate number of records that exist in the table. So let's wait to complete this query, and we will find it contains 50 million records. As you can see it here, we have total 50 million records, and you can see it given the response after 16 seconds 0.284 milliseconds. Now what I'm going to do, I will write one more query that will find out the record of the employee for suppose employee ID 4. So let me do that. So what I can do it here, I can write where condition, and I will write ID equal to 4. Suppose this is the query which I have written, and let me change count1 to star, so that I am asking all the column records which exist for ID 4, that is the employee ID. Let me execute this query, and now you can see it has given me the response in 210 milliseconds. So how quick it is, let me show you with the help of explain query planner as well. So I will write explain analyze, that I already shown you in last tutorial as well. What it will do, it will provide the query planner, and we will found that it is using the index scanning to fetch the records for this employee ID 4. So let me execute this, and here you can see it is doing index scanning using IDX ID, that is the index that I have created on ID column on the employees, and you can see it here, it is executing one loop. And if I come down, you can see one row it has fetched with width 31, that the total data which it is fetching, that total data contains 31 width, and you can see index, it has done index scanning, and then you can see the total execution time that it has estimated is 0.034 milliseconds. So here what we understood is that if we have an index created on that particular column, in that case Postgres will do the index scanning if it found that okay, that index scanning is cheaper for me compared to the sequential scanning. So now let's discuss that when does a Postgres ignore indexes sometimes. There can be multiple reasons. Each reason I am going to discuss in detail. So the first reason is that a filter that we are using in our query that can contain multiple rows that are matching with the condition. Suppose I have written a query, suppose let's say select all from employees where department ID equal to 4. In that case, there can be chances that department ID equal to 4 contain lot of employees record. In that case, if Postgres think that I am doing the index scanning, in that multiple IO operations are needed, and that can be very costly. So in that case, what better approach I can use is that the sequential, not sequential, parallel sequential scanning, that it contains 50 million of records. So better I read the entire table and then I will provide the necessary data to the user. Let me show you with the help of an example. So in place of ID, what I will do, I will mention department underscore ID. And first what I can do, rather than providing the department ID, first let me provide you that how many data contains in each of the department, so it will be easier for you to understand. So I will write select, not select, I will write department underscore ID and department underscore ID, and then I will mention count 1, so that we know what is the count of values or the records for each of the department. And I will group this data by department underscore ID. Let me execute this query and you will find that there are total 6 departments that exist in this table, 1 2 3 4 5 and 6, and for each of the department these are the number of records that exist, as you can see in this screen. For department ID 1, it is 49 lakh records that exist in this table. For department ID 2, it contains 10 million records, or you can say 1 crore records almost. For department ID 3 as well, greater than 10 million records. For department 4, you can see greater than 10 million records. For department 5, as you can see, almost 10 million records. And for department ID 6, again it is 5 million records. So here you can see, if I am writing select all from employees where department ID, suppose let's say 4, in that case 1 crore records or 10 million records are matching the condition. In that case, there are multiple IO operations that are needed to fetch the records. So what Postgres will do, better doing the index scanning, let me do the parallel sequential scanning. Let me show you this with the help of an example. Rather than fetching the entire records, what I will do, I will just fetch the count. So what I will do, I will here write select count 1, and in place of group by I will write where condition. So I will write where department ID equal to, so let's say 4. So if I execute this query, and let me do explain analyze as well, so that we can see what Postgres is doing. Analyze. So let me execute this query, and it will take some time and we will wait for the query planner. So it's got completed and you can see it here, it is doing parallel sequential scanning. Currently there is no index exist on this department ID, but let's say if I'm creating that as well, still it will do the parallel sequential scanning. I will show you this in the later part of this video, so don't worry. So this is one of the use case, that when the filter that I am using in the query, that is collecting lot of records from the table. So in that case, what Postgres will decide, better I am do the parallel sequential scanning, because I can generate multiple worker threads here as well. You can see it here, 2 worker threads are doing the parallel sequential scanning. So it will be cheaper compared to the index scanning. So this is one of the case when Postgres will ignore your indexes. Now the second case is that when the table is very small. In that case as well, indexes are not necessary to use. What Postgres will do, it can do the sequential scanning or parallel sequential scanning. Let's say you have a table with 100 records. So in that case, what Postgres can do, it can do the parallel sequential scanning to provide you the records, because it is very easier for the Postgres to do the scanning on the less number of data set compared to the large number of data set. So ideally it will do the parallel sequential scanning because the size is very small, and if the table is not growing incrementally, what does it means, that you are not doing any insertion on the table, that the table size is consistent, it is, and the new record is not going to be increased in the upcoming time, or you can say in future you are not inserting the values. So in that case, for small tables, parallel sequential scanning is better. So Postgres will do that rather than doing the index scanning. So this is the second scenario. Now let's discuss about the third scenario. As we know that Postgres is relying on the statistics. So if our statistics are old, in that case as well, Postgres will not able to identify which scan it need to do. How that statistics will get old? Let me give you an example. Suppose we have total 50 million records in this table. Now I am doing multiple updates, deletion as well. In that case, what will happen? It will generate the dead tuple in the table, and if those dead tuple will get generated, it will occupy the space in my table as well as in the index as well. So for that, what I need to do, we need to do the vacuum activity, but that is still not enough, because vacuum will remove the dead tuple from the system, but still your statistics will not get updated. So in that case, what we need to do, we need to do vacuum analyze table, so that our statistics index will also get updated along with the vacuum activity, so that it will help us to Postgres to identify the right scan that it need to do. Maybe possible that index scanning is better, but just because of old statistics it is doing sequential scanning or parallel sequential scanning. So to overcome from that challenge, we can do the vacuum activity along with this analyze as well, so that it will help us to update the statistics, and we in a system are storing only the latest statistics. If you are not aware that what is the dead tuple and why we are doing vacuum activity, already I have created a video on that as well. You can watch it out. Suggestion you can see on top right corner. So this is the third scenario. Now let's discuss about the fourth scenario, that is parallel execution. Whenever we are doing the scanning on the table, Postgres will identify that it has to do parallel sequential scanning or index scanning. Now let's say that you are doing the index scanning. In that case, how the things work? First, we will go to the index. We will identify the value, that where that value is present. We will go to the heap memory. We will load that page into the memory, and then we will read the data. This is the process. Now let's say the condition that we have mentioned in the where condition, that is where, suppose let's say department ID equal to 4. Multiple rows are matching. In that case, what will happen? Multiple IO operation will occur. Multiple times I have to go to the heap memory to load the page into the memory. So that is very costly. So better I will go directly into my table, that is heap. I will do this sequential scanning or parallel sequential scanning. I will read the entire data, and then what I can do, I can provide you the necessary data that you are looking for. Other records I can filter out. So this is the better approach compared to the index scanning. If there are multiple records, that I can reduce my execution time with the help of parallel workers. So this is one of the scenario. Now let's discuss the last scenario. Suppose I am using any function. In that case as well, indexes can be ignored. Let me give you an example. Suppose I have written, let's say, select all. Let me write all from employees, where in place of department ID, let me mention full underscore name. And here what I did, I have mentioned employees. First let me show you the records, that will be the better. So I will write select all. Let me remove this analyze, and if I execute this query, so here you can see it will take some time. So let's wait to complete it first. So it will tell us ID, then full name, then salary and department ID. For that, department ID equal to 4. So okay, let me cancel this query because department ID will be multiples. So in place of department ID I can give ID. So you can see it here, it is showing ID, full name, salary and department ID. So what I can do, rather than ID, what I can mention, suppose let's say I have used upper method here, and now what I'm writing, I'm writing full underscore name, and I want to match this name with, suppose, employee underscore 4. Now this records does not exist, but still suppose you have created a index on full name. In that case, what will happen? You are storing the value in form of first letter as a capital letter, then small letter, then underscore, and then digit. Let me execute this query first. So you can see it here, it is taking a lot of time. So as you can see in the screen, it took 19 seconds to provide you the single record. Why that so? Because it has to convert each and every value to the uppercase to match the value that you are looking for. Suppose if you have an index in that column as well, still it will not work for you, because in index as well you are storing the same values. Suppose if you want your index to be used for these kind of queries, in that case you need to create index with the uppercase function. Let me show you. Suppose first you are writing create index, and I have written idx underscore full underscore name on tutorial underscore employees, and ideally what we will do, we will write full underscore name. If we do this, in that case our index will not help us. So what we need to do, when we are creating the index, we need to mention this uppercase function as well, upper, so that whenever it is storing the value in the index, first it will convert the value into the uppercase, and then it will store that index. In that case, if we use that query again, that is the query which I have written, select all from employees, where upper full name equal to employee underscore 4, in that case it will work the index scanning. So these are some of the scenarios where Postgres will decide to do sequential scanning or parallel sequential scanning over your index scanning, even though index exists on the table or the columns. Now let's see a small example, that is the real world example, that we are going to see that even though we have created the index, still our Postgres is using the sequential scanning on the table. So first let me remove this, and what I'm going to do, first I will show you that there is no index for that department ID. So first let me open this SQL. First I will go to the tutorials and I will go to the table section, and here this employees, I will go to the SQL, and you can see it here only one index exists, that is on ID column. Now let me create another index. First let me do the execution without index, and then we will show you that after creating the index as well, it is doing the sequential scanning on the table. So let me write select, and I will write suppose let's say count equal count1 from tutorial dot employees, where my department underscore ID equal to 4. Let's say for this query we already saw for a department ID 4 more than 10 million records exist in the table. So if I do the explain analyze as well, let me write explain analyze. So we will found it is currently doing parallel sequential scanning. That is obvious because index is not exist in the table. So let me do this execution first. Ideally I guess it will provide two worker threads. Those two worker threads will do the parallel sequential scanning. As you can see, it has launched two worker threads, and you can see it here, it is doing parallel sequential scanning. And as we are looking for the count, so it will return a single value, so it will do the aggregation as well. You can see it here, it will gather the actual result and then it will do the final aggregation. And you can see it here, 8653 milliseconds. This is the estimate time it has reflecting. Now let's say I am creating the index on this department ID column. After that we will see still it is not doing the index scanning. So let me open another query tool so that we can compare the results. So let me create an index first. Create index idx underscore department underscore ID on tutorial dot employees, and I will provide department underscore ID. This is the column on which I am creating the index. So let me execute this query, and it will take some time because total 50 million records exist in the table, so it will take some time to create the index. And as we are aware, there are total 6 records which exist for this department ID, that is department ID equal to 1, 2, 3, 4, 5 and 6. So you can understand, suppose if you are looking for the department ID 4 records, so if I know there are total 6 records, even though by default this index will get created on the basis of b plus tree, so that indexing, or you can say the traversing, is log of n. Even though 6 records exist, it is very cheap, but for those record that is department ID 4, more than 10 million records exist. So as I have been able to find out, okay, these are the pages where my department ID 4 record exists, but still I have to do lot of IO operation. Let's say for those 10 million records, 10 million pages exist. In that case, 10 million IO records I have to do. So that is very costly. Even though if it is a single page, in that case, okay, it is fine. I have loaded a single page and then I have provided you the record. But that is not the case every time. It can be data can be present in multiple pages. It cannot be continuous for your department ID. So in that case, what Postgres will do, it will do the sequential scanning, because it will able to identify with the help of statistics that okay, if I do the parallel sequential scanning, it will be cheaper compared to my index scanning. So as you can see, index got created. It took 1 minute and 26 seconds. Now let me copy the previous query. I will execute it here and we will find out that still it is doing sequential scanning, or you can say parallel sequential scanning. So let me execute this query. Let's wait to complete this execution and we will find it is still doing parallel sequential scanning. So with this, what we will understood is that still you are creating the index on the column. It will not able to help you with the performance, because you are thinking after creating the index it will reduce the time. That is not the case. It depends on that how much data you are storing, what query you are writing, and how it will able to help you with the execution. So you can see it here, still it is doing parallel sequential scanning. And now if I go to the SQL as well, let me go to the SQL so that you will be able to see that index got created. If I refresh this, let me refresh, and if I go to this SQL again, so you can see it here. Now IDX department ID is also exist, that is department ID column. I have created an index that is B tree. It is a B plus tree, but by default they will mention B tree. So still the index is present in the DB. It is doing parallel sequential scanning. Why? Because it thinks it is cheaper compared to my index scanning. For index scanning, I have to do lot of IO operation that is very costly. So better I will go to my heap, I will read the entire table, I will find out which all records I have to give it to you, and then I will provide you the records. Any record which you don't want, I will filter it out. As you can see it here at line number 8, it has removed these many rows as well from your pages, because in a single page it is not like that only department ID 4 record exists. It can be department ID 1, 2, 3, 6, 7, 9. Again, some multiple records exist for that particular table, so it has to filter other records as well, and it has to provide only necessary records to you. So as you can see, it is taking, or it is suggesting or estimating 7156 milliseconds of execution it will take if you execute this query. So with this, what we understood with the earlier scenarios that I have discussed is that when we are doing the execution, when Postgres will decide to do the sequential scanning, first case is that if the multiple record exist on the filter, that there are multiple records that are common records that it has to fetch, better it will do the sequential scanning because it is cheap compared to my index scanning. Second is that even when my index scanning is better, it can be helpful for me, but my statistics are older, it is not up to date. So in that case, it will do sequential scanning or parallel sequential scanning. So if I update my statistics with the help of analyze query, then it will be easier for me or for the Postgres to decide that okay, now the statistics I have, that is the latest statistics, and for that I am able to understand okay, I have to do the index scanning. Because if you are creating the index but your statistics are old, in that case still it will not help you with the performance. Every time it is doing the sequential scanning, so to help you with the execution, you have to update your statistics as well for that particular table. And the third one is that the planner is suggesting that the sequential scanning is cheaper compared to the index scanning, that we already discussed. If multiple rows are returning, multiple IO operations are included, in that case it is very costly. So better we will go to the heap, we will read the entire table row by row, and we will filter out the unnecessary columns, and then we will provide the necessary columns to the user. So that will be more cheaper. So now let's discuss one scenario, that suppose if you are thinking what will happen if we do the index scanning. As you can see, the Postgres with the help of planner, it is suggesting that if I do the sequential scanning, this is the estimate time I need. But let's say you want to see that when a index scanning is happening, in that case how the things will work. So what you need to do in that case, you have to disable the sequential scanning. So for that there is a query that you need to write. So that is not the recommended approach, that is only you can do for the debugging purpose or testing purpose. I will not suggest you to do this in the production environment or even for your development environment as well. Just for the testing scenario, that you want to see that if I do the index scanning or Postgres will do the index scanning on the table, how much time it will take or how much time it is estimating. For that purpose only I am telling this. Keep this in mind that don't do these things in the production environment, it will not going to help you. So for that what you need to do, you need to write set and you need to disable the sequential scanning. So I will write enable underscore SCQ scan, and if I keep it off, in that case what will happen, it will disable the sequential scanning and it will try to do the index scanning if the index is present. But as I suggested, don't do this in the production and development environment, only do for your debugging purpose. After that you have to enable this. So to summarize, today we have discussed that what is the sequential scan, and then we have discussed that when Postgres will decide to do sequential scan over index scan, even though index exists for the DB. Along with this, we have seen one example, real world example with the 50 million records, that we have shown you that we have created the index, still it is doing sequential scanning because there are multiple records that exist with that filter. So it's better the Postgres is decided to do the sequential scanning over index scanning. And after that we have discussed that how we can disable sequential scanning if we want to debug that what will happen if our index scan will work. So that's it for today's video on Dev Portal. If you found this video helpful, don't forget to like this video, subscribe to Dev Portal and share these videos with your fellow developers and colleagues. Notes link I will give you in the description box as well as in the comment section, so you can check it out. And I will see you on my next video where I will discuss that what is the difference between index scan and index only scan. So that is also very important topic that you should be aware of during your performance tuning. If you are doing performance tuning on database, you should know that what is the difference between index scan and index only scan and how it will going to help you. So stay tuned, I will discuss this in my next tutorial, and happy coding.